right, welcome to our last lesson, a last video for this course. We are on to section 6.6, lesson 6, and it's called Applications of Pythagorean Theorem. So in this lesson, we're going to basically put together everything we learned from the unit, including Pythagorean theorem from earlier on in the unit. We're going to continue with a problem solving type questions as well, and still working on volume questions. So it's just basically putting everything we've done in the unit together. If I take a second here to remind you how to do Pythagorean theorem, that could come in handy here as we move down towards our lesson. All right, so just really quick, the formula for it was c squared equals a squared plus b squared. So if I were to draw a triangle, and it has to be, this formula only works with right angle triangles. That means 90-degree angle triangles. That's your 90 degree right there. All right. And let's say I made up values here. Let's come up with some straightforward values. So let's do a 5 here and a 3 here. And let's say I asked you to find this side here. So I'll call this x. All right, so using Pythagorean theorem, we can find that unknown side. There was one thing that I told you in the lesson that you just had to make sure, as you sub these numbers into your formula, you had to make sure that the longest side, called the hypotenuse, that number has to be your c in the formula. It has to be. And then the a and b don't matter. So whether you call this a or whether you call this b or vice versa, that doesn't matter. As long as the 5 is your c value in the formula, then you will be good. So let's write in now. Let's replace c with 5. And remember, it's c squared, so it's 5 squared, equals, let's call a 3, so it becomes 3 squared. And then let's call x, let's just call it b. All right, so I'll just leave it as b. It doesn't matter what letter you call it. So I'll just leave it as b squared there. All right, so now we just have to solve this equation. We have to solve for b, which will tell us what x is here. So, I mean, let's do what we can calculate right now. I can do 5 squared on my calculator or in my head, and I know that 5 squared is 25. And I can do 3 squared in my calculator. That is 3 times 3, which is 9. Careful, it's not 3 times 2, which is 6. 3 squared means 3 times 3, which is 9. And then rewrite the rest. Now I need to solve for b. So if I think back to our previous unit when we solved equations, I need to get b by itself, which means I've got to get all the numbers to one side of the equal sign. So I'm going to bring this 9 over here on the other side of the equal sign so I can leave b squared by itself. Well, what operation is in front of this 9 right now? Well, it's a plus 9, right? Because I can rewrite this as b squared plus 9 or 9 plus b squared. It's irrelevant, but that just shows you that if I wrote this as b squared plus 9, that this is really a plus 9 here. So on the other side, it's going to become the opposite of plus, which is minus. That keeps our equation balanced if we subtract 9 from both sides. Now 25 minus 9 is 16. Now a lot of you will stop there and say, oh, b equals 16. But no, b squared equals 16. So the last step you do to do the opposite, we've got to move this square over to the other side. And the opposite operation of squaring is what's called the square root. Okay, so when you bring it across the equal sign, you want to square root 16, and that equals b, whatever the square root of 16 is. If you were to pull out your calculator, you would see that the square root of 16, or what number times itself 2 times, is 16? The answer is 4. because 4 times 4 equals 16. So we're going to apply this. So I really wanted to refresh your memories on that because it was a few lessons ago. But we are going to apply this in this lesson here, as well as all our volume questions or volume formulas, and as well as our problem solving step-by-step process that we did in the last lesson. All right, let's take a look at a question. So the Geo Bellies company wishes to make a new type of container for their product. The designer has created two containers, one the shape of a square-based pyramid and the other a cone. Your job is to determine which container holds more. All right, and then it's broken down step by step as to what this question is asking us. Which one will hold more? Well, what are we dealing with, or what are they asking for when they say which one will hold more? If you guessed volume, you're correct, right? It's like if you were to fill this up with a glass of water, which one can hold more water, right? So that, in that case, we are talking about the volume. So we essentially have to find the volume for this and the volume for this and see which one has more. Okay? Now, it's broken down here step by step, so you don't have to jump right to finding the volumes. It's actually broken down, and you'll see why as this comes together, why it's broken down this way. All right, so it almost does the problem solving process for you. It kind of does that step where you have to develop the plan. It's doing it for you because it's asking you step by step what to do. All right, so it says determine the height of each container, show all your work. Well, to find the height of these containers, if I look here, a lot of you will look at this and say, oh, this is the height. That's actually not the height. That's what's called the slant height, and it's different. Here is the height of this pyramid, right there. That's my height. I'll call that H. Okay? The slant height is actually the length of this slant line, this slanted line going this way. So it's actually that which is 10. All right? And this, well, if our whole base is 12, what do you think the distance is from here to here? If the whole length is 12 from here to here. If you guessed half of 12, you're right. So it is 6. So you could see inside of that square-based pyramid, we have to find the height because our volume formula has height in it. And I have to calculate height first by using, guess which theorem, because there's a right angle triangle in there, the Pythagorean theorem. So I'm going to draw this triangle separately so we can see it a little bit nicer. Here's your 10. Here's your H, which we're going to find. And there's your 12. So let's split up. I'm going to find the height in two different spots. So this is going to be the height of my pyramid. So I'll just label it pyramid here. And over here, I'll find the height of my cone. All right, so let's do this. Now, I told you that the Pythagorean theorem is c squared equals a squared plus b squared, right? Well, remember what I said. The longest side has to be your c. Sorry, and I just realized I made a little mistake here. That should say 6. So your longest side has to be your c. So I have to do my c here as 10 squared equals. Now, it doesn't matter what I call a and b. All right, doesn't matter. I'll call my a, I'll call my 6 an a. So I'll do 6 squared plus b squared. Do exactly what I did above. 10 squared is 100. 6 squared is 36. Okay. Subtract 36 on the other side. So exactly what I already did above. So I'm going a little bit quicker now. Okay, so you get 100 minus 36 is 64. Final step, square root the 64 to remove the squared from the b. So square root of 64, well, if you punch that into your calculator, you will get 8. So 8 centimeters, I should put the units there. 8 centimeters is, in fact, the height of your square-base pyramid. Let's do the cone. All right, so still our slant height for the cone is a 10. All right, so the slant height there. The diameter of this circle all the way across is 16. So how large is this half distance here? Half of 16 is 8. So let's draw the triangle now. It's a right angle triangle. There's my 10, there's my 8, and let's call this height. Let's write out the formula to find out what that height is of that cone. Remember that your C has to be that longest slant there. So that's my 10 squared, 8 squared, and then let's call my height, let's just call it B. So this is my A and that's my B. All right, so let's continue. Again, punch 10 squared into your calculator, you get 100. 8 squared is 64. Rewrite plus b squared. Now, remove the 64, so subtract it on the other side. $100 minus 64 is 36. Last step, square root 36, and you get 6. So, the height of my cone is 6 centimeters. The height of my pyramid was 8 centimeters. This will be interesting to see which one gives you the larger volume. All right, maybe we shouldn't assume that right away the cone will give us a smaller volume just because the height is smaller. All right, so let's not assume just yet. I mean, let's double check and actually calculate the volume for each shape. All right, so once again, I'm going to split this up into 2. Okay, here's our pyramid. Here's our cone. So if you look up in your formula sheet, the formula for the volume of a square-based pyramid, you will find that the formula is V equals B squared, which is the base squared, times height, divided by 3. So B squared times height divided by 3. All right, let's write out what B is. What's the base of my pyramid? Let's go to my drawing. The base of my pyramid is 12. That's the base length of my pyramid. And what's the height of my pyramid? Well, I calculated it. It's 8. All right, so let's go back and let's go. My base is 12. My height is 8. Now, all I have to do is plug these numbers into my formula and solve for the volume. So b squared, which is 12 squared. Like, careful that this b isn't the same as the Pythagorean theorem b. Be careful there. That b it's a separate formula, totally separate formula, and it represents the base length of your square base pyramid. All right, so that length is 12. So 12 squared times my height, which is 8, divided by 3. All right, so 12 squared, remember, follow BEDMAS, right? 12 squared is 144. So do that in your calculator, 12 times 12. All right, and then you can do, right, you got to do exponents before you multiply. So you got to do that 12 squared before you multiply by 8. So 144 times 8 now is 1152 divided by 3. Final answer is 384. Write your units, centimeters. Now this is volume, so is it centimeters or centimeters squared or centimeters cubed? If you guessed cubed, you were correct. For volume, it's always cubed. All right, so there's my volume there. Let's see what the volume of the cone is. So remember, this is a totally different shape. It doesn't matter if the height is smaller. This is a totally different shape. Let's see if a cone can hold more even though the height is smaller. Let's find out. So let's look up the formula for the volume of a cone. It is V equals pi times r, or the radius squared, times the height of your cone, divided by 3. All right, so what is the height of my cone? I'll just write it off to the side here. Well, I found it here, right? It's 6. That's the height of my cone. And my radius, which I have to sub in there, what's my radius? Well, if the diameter is 8, or sorry, if the diameter is 16, the radius must be half of that, which is 8. Okay, let's plug everything in. So V equals, I don't have to write the V all the way down, so I'll just write equals pi times r squared, so that's 8 squared, times my height, which is 6. And that's all divided by 3. Don't forget the divided by 3. A lot of students forget that. Let's follow BEDMAS. Do 8 squared before you do any multiplication. So write your equal sign, put your pi again. 8 squared is 64, so it's times 64 times 6. And then again, don't forget the divided by 3. Now I can multiply across the top. All right, and then divide by 3. So do in your calculator 3.14 for pi times 64 times 6, press equals, and then divide by 3, and look at what you get. Interesting. Actually, let's round to the nearest whole. Since we don't have any decimal places in our question, I'm going to round to the nearest whole here. Look at what you get. You get 402 centimeters cubed. Remember, it's cubed. So wow. So even though that cone had a smaller height, all right, but it had a wider base length, right? Because the diameter was 16, whereas the square base pyramid, it was only 12, right? So this cone actually, even though it was shorter, but it was a little bit wider, has or can hold a larger volume. Now, look at this next question. This is kind of a problem-solving question now, right? We've got to find out a way. So it says if the geobellies cost $0.005 per centimeters cubed. $0.005 per centimeters cubed is really just a half of a cent. All right, so it's a 0.5 of a cent. How much will it cost to fill each container? How much will it cost each container? All right, so before we get started there, I want to look back at what we did in the previous lesson with respect to the problem-solving process. Okay, so step 1 was to understand the problem and to write out what's given and then write out what you need to find. Okay, draw a diagram if you need to, reword the question, or estimate what you think the answer can be. Then we're going to develop a plan. Okay, so we're going to work backwards to try to develop a plan. All right, what do we need to solve along the way? All right, and then let's write out the formulas to solve it, and then decide what order to solve all your items in. Okay, so let's go back. All right, so here we go. Let's write down what we have or what we know. Okay, so let me write that down. Okay, so what we know is that the cost is 0.005 cent per centimeters cubed. I also happen to know from the previous question, I know that the volume of my pyramid, so I'll call it V subscript P for pyramid. Okay, so that's a lowercase subscript P. That was 384 centimeters cubed. Right? I also know the volume of my cone. That was 402 centimeters cubed. All right. Okay, so now, where do we go from here? I mean, do we have to write that we know what the heights are? I don't think, I mean, the heights only helped us find the volume. Like it was kind of, that's kind of behind us now. We don't really have to show that we know what the heights are. Let's just write down that we know what the volume is and we know what the cost per unit volume is. So this is kind of like the unit cost, right? So it's half a cent for every centimeter cubed. Okay, so now we have to start to try to develop a plan, right? Because we know that we have to find the total cost to fill each, right? Like that's what we need to find. So how are we going to be able to work backwards to find that? Well, let's stop and think here. If I know that it costs me $0.005 or half a cent, all right, and that fills up how many centimeters cubed? 1 centimeter cubed, right? That's what this means here. It means that it costs half a cent per 1 centimeter cubed, all right? We want to know how much will it cost, all right? So let me call this my cost for, let's say that this is for the pyramid, okay? So the cost for the pyramid, so I'll call it cost and then I'll put like a subscript P there. All right, so cost for pyramid, I don't know what that is, so I'm just going to leave it as the word cost right now. But I know that I have to fill up 384 centimeters cubed worth of this product. So I know how much it costs for 1 centimeter cubed. How much does it cost for 384 centimeters cubed? Stop and think about this for a sec. All right, let's stop and think about this. If I know how much it costs for 1 centimeter cubed, how can I, these are proportions here, all right? So it's going to stay with a consistent proportion. How much will it cost to now fill 384? Well, let's try this, since this is what's called a proportion. How much did it cost, or what did I do to go from 1 centimeter cubed to 384 centimeters cubed? What did I multiply by? How many times bigger did my 1 get than 384? It got 384 times bigger. So if that's my proportion factor, it has to be the same proportion factor on this side. It has to be. So if I went from 1 centimeter cubed to 384 centimeters cubed, that means that I got 384 times bigger. My volume is getting 384 times bigger. So my cost has to also get 384 times bigger. So the cost, or let's call it C, capital C, and then subscript P for the cost of the pyramid is equal to, okay, 0.005 times 384. Okay, so times 384. And what do you get in your calculator? Make sure you put enough zeros here. It's decimal 005, so 2 zeros there, times 384. You get $1.92. that's the cost to fill up that pyramid. Okay, so hopefully you're with me here. I got 384 times bigger on this side, which means I also have to get 384 times bigger on that side. So I did 0.005 times 384, and that gives me the cost. Okay, let's finish this off and let's find it for the cone. Okay, so for my cone, so I'll split this up, it still will cost $0.005 or half a cent to fill 1 centimeter cubed. But I have 402 centimeters cubed for the cone. How much will it cost? Let's call it C, and then because it's a cone, so capital C, subscript C, cost of cone. So how many times bigger did I get on this side? 402 times bigger. So what do I have to do on this side as well? Also multiply it by 402. So my cost of the cone is equal to 0.005 times 402. This is going to be obviously more expensive to fill because it's bigger. It's going to cost $2.01 approximately. Okay, or approximately $2. So there it is. My cost of the cone is $2.01, whereas my cost to fill up the pyramid is $1.92. Did we answer the question? If the geobellies cost half a cent per centimeter cubed, how much will it cost to fill each container? Yep. This is your answer here. And that's your answer here for the cone. Okay? Make sure you organize your answers neatly so that they're easy to mark. So, where I split this up, I really should label this cost for cone. So I'm labeling it. Okay? And then up here, I'm kind of at a space there, but you want to label that as cost for pyramid. Okay? So make sure that you're organized. You split things up if there's multiple calculations. Okay? This is really good what I did here in terms of cost of cone, all right? So capital C, subscript C, cost of cone, but I also labeled it here as well. Okay, so that if somebody's marking or reading my work, they know what I just calculated. It's your job to make sure that that happens, okay? That it's clear enough, it's organized enough where somebody who's marking it can just look at it and know exactly what you're solving for. All right, so please make sure that your communication skills are strong here, because these questions can get, there could be a lot of parts to these questions, and you have to make sure that you are communicating properly, labeling things properly, organizing, splitting things up properly so that it is easy to read and mark. All right, so that concludes, everybody, the final lesson of this course. I hope you're pretty excited. Okay.